we just learned if they're independent, then the probability of A given B is exactly the same as the probability of A. This is a lot of theory, so it's kind of hard to follow, so stay with me. Okay? If you look over here, this is the probability of A given B. If they were independent, that would just be the same as the probability of A. So if I have independent events, then that would be the same as the probability of B times, I don't need the given, right? In independent situations, the given doesn't impact the original probability, so that would still just be the probability of A equals the probability of A and B. Okay, so these are the two multiplication rules that we need to know, because these situations are gonna show up quite a bit. All right, so let me show you how to apply one of these in each situation. Okay, this situation. If I told you guys, what if I wanted you guys to pick two cards? Multiple events, right? I'm picking two cards instead of one. I've got multiple events here. What if I said, what's the probability that the first card is a heart and the second card was a club? Okay, so really if I'm applying this, the first event, the probability of B, that's the first card being a heart. So that would be the probability of the first card being a heart times, just going off of this formula, the probability that the second card was a club given that the first card was a heart. Okay, so picking your first card as a heart. How many hearts do you have in a deck of cards? There are 13 hearts in a full deck of cards of 52. But then I have to multiply it with the number. Now, what's the probability that the second card is a club given that the first card was a heart? Well, if I've picked a heart already, I'd no longer have 52 cards in the deck. Now I only have 51. And out of those 51 cards that I have in the deck, how many of them are clubs? There would still be 13. So now all I have to do is multiply them. So I get my nice calculator out. All right, so it's 13 over 52. And then I multiply that by 13 over 51. And there's my probability. It's about 0.0637. So there is only actually about a 6% chance that if I pick two cards in order, the first one is a heart and then the second one is a the second one is a club. Okay. Kind of a similar to situation. What if I said I pick two cards? What's the probability that the first card is a heart and that the second card is a heart? Okay, so according to that formula we just wrote, that would be the same as finding the probability that the first card was a heart, and then multiply it by the probability that the second card was a heart, given that the first card was also a heart. Okay, so this first one, probability that the first card is a heart. Well, how many hearts are in a deck? We got 13 out of 52. Now I have to multiply it. If I knew that my first card was a heart, I picked that card out without replacement. Now I only have 51 cards in a deck. But I've also already picked a heart, so how many hearts are left? I don't have 13 anymore. Now I only have 12. So if I multiply these two numbers together, we got 13 over 52 times 12 over 51. The chances of this happening, 0.0588. There's only about a 0.0588 chance of that actually happening. So to pick two cards in a row and have them both be hearts, there's only about a 5.88% of that happening. Okay, So that's the situation of event. This is what happens if you have events that are not independent of each other. What if they are independent? Okay. Best case example I can think of, what's the probability of having one boy when a couple has 3 children? Okay, now there's 2 really important things to know. Okay, one, this situation should be independent. If my first kid is a boy, that's going to have no impact on what my second kid is or a third kid is. Okay, so every single kid, the sex of that baby is independent of the other. So that's how I know that we're working in an independent situation. Second, you have to remember in these cases that order matters. Okay, so we have 3 children. What way could you have 3 children? You could possibly have all 3 boys. Okay, you could have 2 boys and a girl, but there are so many different ways you can have 2 boys and a girl. You could have boy, boy, girl. You could have boy, girl, boy. Or you can have girl, boy, boy. So order matters in this situation, okay? Or we could have 1 boy and 2 girls. But the order of having these kids also matters. So you can go boy, girl, girl. You can go girl, boy, girl. Or you can go girl, girl, boy. And then the very last scenario is you could have all 3 girls. Girl, girl, girl. Okay, so in this situation, what is the probability that we have 1 boy? Okay, so I had 3 boys here, 3 boys. How many situations did I just have 1 boy? There's 1 situation, 2, 3. Okay, so the probability of having 1 boy when I have 3 children, well, there are 3 different situations, 3 out of a total of 2, 4, 6, 8 possibilities. Now, what if I was just picking one of these events, right? What if I said, what's the probability of having a boy? The first baby was a boy, the second baby was a girl, and the third baby was a boy again. What's the chances of this happening? Because these are all independent of each other, what I can just do is just multiply them. The probability of having a boy, let's assume, is 50%, so 0.5. The probability of me having a girl is 50%, 0.5. And the probability of me having that third boy is 50% as well, or 0.5. So I just take these numbers and I multiply them together. That's the same as 0.5 to the third power. And I get 0.125. So when they're independent events, you just multiply them together and you're good to go. Okay? All right. Now we've got the multiplication rules down. We've got independence down. I've got about 10 more minutes before everybody goes crazy. A lot of times when you're doing multiplication rules, the easiest way to set these up is having a tree diagram. And yeah, let's go with it. So let me give you a scenario. Okay? Let's say in my honors classes, we have 15% receive A's. Okay, we'll say 25% get B's. We'll say 35% get C's. 15% get D's. And then we'll say 10% fail. They get F's. Okay? And that should equal 100%. Let's make sure that's 25, 50, 85. Yep, so there's 100% of my students accounted for. Okay? And then we'll say, of the students who receive A's, and I'm just making this up, we'll say 80% go to college. All right, of the students who receive B's, we'll say 70% go to college. And then we'll go down the line. The students that get C's, we'll say 65% of those students go to college. Students who get D's, we'll say 40% of those students go to college. And the ones who fail, we'll say 23% of those students go to college. So I got a lot of information here. And it's really hard to organize this and kind of keep it up, especially if I said, what's the probability of a student going to college? In my